Hello everyone. Welcome to section 6 on async and context. We again have a server that registers tools and a client that calls them. This section adds two new capabilities. Tools can push log messages and progress updates to the client while they run. And a tool can mutate server state and notify the client that the resource list has changed. The server and client support both transports, STDIO and streamable HTTP, and you can switch between them by commenting and uncommenting a single line in both files. With STDIO, the client spawns the server as a subprocess, and they communicate over standard input and output. No network, no ports. You only run the client. It manages the server process. With streamable HTTP, the server runs independently as a web server. Start in one terminal, then run the client in another. The tool calls are identical either way. The transport is the only thing that changes. Let's begin part 1, the server. Fast MCP registers tools and resources. Context is the type annotation for the dependency injected context object. Fast MCP detects it by type and passes it automatically at call time. So the caller never provides it. Server session parameterize context, giving the type checker visibility into session level methods like context.session.send resource list changed. We'll get into this as we go along. First, this one line creates the server. Recipes is module level mutable state. Next, dynamic resource get underscore ingredients. You've seen this in our previous video on resource template. The dish is the URI template, is a path parameter. FastMCP extracts it and passes it to the function. This resource is dynamic. It resolves against live recipes dictionary state at call time, not a fixed list registered at startup. Tool 1. Generate shopping list. This tool has context notifications. Consider this as a shopping list generator. It deduplicates and sorts ingredients across all requested dishes. If the list is empty, it logs an error and returns early. For each dish, it reports progress, looks up ingredients in the dictionary, logs a debug message on success, or logs a warning and skips if the dish isn't found. The CTX parameter is injected by FastMCP, never passed by the caller. It provides 5 push mechanisms, all awaitable. CTX.error on message sends a logging message notification with level equals error, does not raise or stop execution. It is a notification, not a Python exception. CTX.info of message, general status updates during processing. CTX.debug on message, fine-grained trace messages. CTX.warning of message, non-fatal issues. An unknown dish triggers a warning and the loop continues. CTX.report underscore progress. With progress, total, message. Sends a progress notification. None of this appear in result.content. They travel as separate protocol messages before the tool result is returned. Tool 2. Add underscore dish. This is resource mutation and notification in action. Consider this as a dish registration tool. Writes a new entry into the shared recipes dictionary, then notifies connected clients that the resource has changed. CTX.session gives direct access to the underlying server session. Next, starting the server. Comment, uncomment to switch. With stdio, run the client only. It manages the server subprocess. With streamable HTTP, start the server in one terminal, then the client in another. Part 2. The client. Async IO runs the async client. JSON pretty prints the tool list. OS and sys resolve the virtual environments path. Any URL constructs the typed URI for read underscore resource. Client session manages the MCP session. Types provide text content and text resource contents for instance checks. Both transport clients are imported. Only one is active at a time. Next, underscore Python walks up two directories from the section folder to reach the demo root and builds the absolute path to the virtual environment's Python interpreter. stdio server parameters describes how to launch the server subprocess. stdio transport only. Next, callback functions. These are the two hooks the client registers to receive server-side push notifications. This is new in this section. Underscore logging underscore callback is registered once on client session at construction. It fires whenever the server calls ctx.info, ctx.debug, ctx.warning, ctx.error, params.level. Params.level tells you which one. Params.data carries the message. Underscore progress underscore callback is registered per call on call underscore tool. It fires whenever the server calls ctx.report underscore progress. The three arguments match exactly what the server passes: progress, total, and message. Let's get into actually running this. First, we open the connection. This one line is the only thing that changes between transport. Comment out one, uncomment the other, client session, initialize, and all tool calls stay identical. stdio underscore client uses server underscore params to spawn the server as a subprocess and returns read-write streams connected to it. Streamable HTTP connects to the already running server by URL. Client session wraps whichever streams come in and handles the MCP protocol. The logging underscore callback is registered here at session construction, not per call. So it receives log notifications from any tool on the server. Session.initialize performs the handshake. Our first call, list tools, what the server exposes. Let's first run the client and see this in action. It runs successfully and as expected. Let's concentrate on what list underscore tool gives us. CTX is absent from both input schema entries. Both tools registers context as an argument. Add dish has that a third argument, and so does generate shopping list. Fast MCP detects it by type, injects it automatically, and strips it from the public schema. Callers never see this. First, list string maps to an array with items. Generate shopping list.dishes is typed as list string in Python. In JSON schema, it becomes type of array, items will be type of string. This is the standard JSON schema representation for a typed list. Both lists have output schema present with result type string. Both return plain string. FastMCP wraps a plain string return and generates the schema automatically. Next, invocation 1, generate shopping list, empty list, and context.error. Context.error arrive via underscore logging callback before the raw result. The notification fired as the server executed context.error before the return. Is error equals false, even though context.error was called. Context.error is a log level, not a failure signal. The tool returned normally. Underscore progress underscore callback was registered, but never fired. The server returned before reaching the progress loop. No report progress lines appear. Progress error, no dishes provided. Underscore progress callback was registered, but never fired. The server returned before reaching the progress loop. Structured content, result, no dish provided. Fast MCP, wrap the plain string return. Invocation 2. Generate shopping list, known plus unknown dishes with context warning. Here, if you look closer, all notifications arrive and prints before raw result. The tool result only arrives after the function returns. The sequence reflects execution order on the server. ctx.info, ctx.report progress, and ctx.debug are interleaved exactly as the server emitted them. Two callbacks, underscore logging underscore callback and underscore progress underscore callback, ran together in that order. ctx.warning is non-fatal. Soup is skipped, but the loop continues. The final list contains only ingredients from the three known dishes, deduplicated and sorted. Invocation 3, add underscore dish, resource mutation, and send resource list changed. Here, there's no ctx.info, debug, or warning lines. Add underscore dish calls none of them. The only notification it sends is send resource list changed, which is a different notification type and does not go through underscore logging underscore callback. Notification added risotto in the output is the tool's return value read from result.content, not an actual MCP notification. The label is just how the client print was named. Recipe risotto did not exist before this call. After add underscore dish wrote to the dictionary, session.read underscore resource resolved it immediately. The same get ingredients function now finds risotto in the dictionary. And finally, we have our async main function. In closing, we learned two mechanisms let the server communicate with the client while the tool runs: logs and progress notification. Context.info, debug, warning, error, and report progress all send protocol level push messages. They arrive before the tool result in execution order. The client receives them through two callbacks: logging underscore callback, registered on client session, fires for all log levels for any tool, and progress underscore callback, registered on call underscore tool, fires only for context.report progress. Per call, neither callback touches result.content. They are entirely separate from the tool return value. Context.error is a log level, not a failure signal. It does not set is error equals true. Next, resource list notification. Context.session.send resource list change is a separate notification type. It tells the client the set of available resources has changed. It does not go through logging callback. After a tool mutates server state, any resource backed by that state is immediately resolvable. The client can call session.read underscore resource straight away. And now, let's switch the transport to HTTP and see this in action. I comment out this line and uncomment this line to the transport and change the transport. That takes care of the server. Let's save it. Let's just run the server and make sure that server starts up. The server is running as expected. Now next, let's make a change to the stdio client and make the streamable HTTP client active. Let's save this, open another terminal, and run the client. We've run the output and everything looks just as expected. We covered a lot today. Now, dive back in. Run the code, rewatch it, break it, and rebuild it. That's how you actually learn. Make it your own. Thank you.